So in this series of MSAT physics, we will try to understand about gravitational force. We will also be seeing at different laws of motion, which is Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. At the end, we will try to understand that what are the conditions for static equilibrium. Along with that, there will be some practice questions that will help you out to understand the topic more. So the very first thing that we should understand is the gravitational force. Okay, so what exactly a gravitational force is? So we all know with the story of falling apple, why anything falls towards the earth, or why planets are revolving around the sun, and what is making that entire universe, who is holding that. So that answer is basically gravitational force. So gravitational force is a force because of that the apple is falling, because of that earth, the planetary system of motion that is existing, and that's why we are understanding what is the gravitational force. Okay, so to understand in detail, this topic itself is very wide, but for MSAT physics, what is required, we'll try to understand that part. So number one thing, that what exactly gravitational force is. So gravitational force is that any two objects, let's say this is object 1 and this is object 2. So this force is always attractive in nature. This any two objects in universe, they will try to attract each other, and the value of that attraction force is proportional to the product of the masses. So let's say this object has mass m1, this object has mass m2. So this gravitational force is proportional to the product of the masses, and this gravitational force is also inversely proportional to the square of distance between them. So let's say distance between these two objects is r, so square of r. So this force becomes g m1 m2 by r square. Okay, so F is proportional to product of masses, F is inversely proportional to the square of distance between them. Okay, there is also a constant come when we remove the proportionality sign, which we called as a universal gravitational constant, that is fixed value universally. Okay, and its value is 6.67 into 10 to the power minus 11 Newton meter square divided by kgs. Okay, so that's the value of capital G. Let's understand what exactly the statement is. That gravitational force is a force of attraction between any two objects. This force is always attractive, means that everything will pull towards each other, and strength of this force is basically depends on the masses and distance between them. Okay, now we always come across a value which is small g. We always say this is a gravity, that is a gravitational force, but actually small g is not gravitational force. Small g is the acceleration due to gravity. Okay, so if I say that any object having mass mass having m, so the weight of the object or the gravitational force on this object is mg, so the small g is nothing but gravitational acceleration, and value of this small g is not constant. This value varies, but near to the surface of earth, this value g is approximately equal to 9.81 meter per second square. You can also verify the unit of small g is meter per second square. That means it is not a force, it is a acceleration. So whenever you have to find mass or a weight, a weight of any object, you can take small g as the value. Okay.